For roughly 14,000 years, the British Isles were essentially empty. Not sparsely populated, empty. Buried under ice sheets thick enough to bury entire mountain ranges, the landscape simply couldn't support human life. And when that ice finally began retreating at the end of the last ice age, one of the enduring questions in British archaeology has been surprisingly simple to ask and stubbornly difficult to answer: exactly when did people come back? For decades, the accepted timeline placed that return at a specific point tied to a well-known warming signal recorded in Greenland's ice cores, a signal scientists have used for years as the default clock for climate change across all of northwestern Europe. But new research is now rewriting that timeline for Britain specifically. According to a study published in the journal Nature Ecology and Evolution, people were already moving back into the British Isles around 15,200 years ago, nearly 500 years earlier than previously assumed. That gap might sound small on a geological scale, but in human terms, it represents 20 entire generations returning to this landscape earlier than the textbooks said they did. And the evidence for this revised timeline didn't come from a new fossil, or a new skeleton. It came from something almost nobody would think to look at: the quiet, undisturbed bottom of a single lake in South Wales. To understand why this timing matters, it helps to picture just how hostile this landscape was before the thaw. At the height of the last glacial maximum, roughly 20,000 years ago, ice sheets covered most of the British Isles, extending across mountain ranges and valleys alike in a landscape almost completely without vegetation, without large animals, and without people. South of the main ice sheet, conditions weren't much more welcoming: a wind-scoured, barren landscape offering little in the way of food or shelter. But glacial retreats rarely happen instantly. As temperatures began creeping upward, the ice sheet's edge slowly gave ground, meltwater pooling and trickling across newly exposed rock. Hardy tundra plants were often the very first sign of change, taking root in ground that had been locked under ice for millennia. And where plants led, animals followed. Reindeer, adapted to exactly this kind of marginal, cold-tolerant grazing land, began cautiously testing the edges of the retreating ice, drawn toward newly thawed grasses. It's easy to imagine this transition as sudden and dramatic. In reality, it was patient, incremental, and almost entirely driven by which plants and animals could tolerate the changing conditions first, setting the stage for everything that followed. Humans didn't lead this migration, they followed it. As reindeer and wild horse herds expanded into newly available grazing land, small bands of late Upper Paleolithic hunter-gatherers, fully modern humans by this point in our species' history, tracked those animals northward across the still exposed land connection joining Britain to continental Europe. This wasn't yet the island nation it would eventually become. Sea levels hadn't risen enough to sever that connection, meaning people and animals alike could simply walk across what is now open water. The archaeological record from this period is thin but genuinely important, concentrated at a handful of key sites: Kent's Cavern in southwest Britain, Gough's Cave in the Cheddar Gorge region, and a cave in the Wye Valley in Wales that has produced some of the earliest confirmed human remains from this period anywhere in the British Isles. These groups moved in small, mobile bands, following herds rather than settling permanently, building temporary shelters and hearths that left behind exactly the kind of sparse, hard-to-date evidence that has made pinning down their exact return date such a persistent challenge for archaeologists. That challenge is exactly what led researchers to Llangorse Lake, also known as Lake Sifidin, in South Wales, a site that turned out to hold something genuinely rare: an almost continuous, undisturbed environmental record stretching back roughly 19,000 years. Lakes are remarkably good at quietly recording history. Every year, fine sediment settles to the bottom, layer upon layer, and everything living in or around the lake at the time, pollen from nearby plants, the remains of small aquatic insects, trace chemical signatures, gets locked into those layers along with it. Llangorse Lake also happens to sit close to that same Wye Valley cave with the region's earliest human remains, making it an unusually well-positioned site for connecting environmental change directly to human activity. Researchers extracted long cores of this ancient sediment and began reading it much like a very slow, very precise diary, one written not in words, but in pollen grains, insect remains, and the seasonal rhythm of thousands of accumulated years. The specific tool that made this reconstruction so precise involves tiny insects called chironomids, non-biting midges whose larvae are remarkably sensitive to water temperature. Because different chironomid species thrive at different temperatures, the specific mix of species preserved in a given sediment layer can be used to estimate the temperature of the water, and by extension the surrounding climate, at the exact time that layer was formed. When researchers worked their way up through the Llangorse Lake sediment core, they found something abrupt, a sudden shift in the chironomid community, alongside a matching shift in the fossil pollen record from cold-tolerant tundra species to warmer climate vegetation. This wasn't a gradual warming stretched across centuries. It was a sharp transition, and dating it precisely placed it at roughly 15,200 years ago, a full 500 years earlier than the point most previous models had assumed for this kind of warming in Britain. Reindeer and horse presence in the archaeological record nearby appeared to track closely with this shift, expanding into the region right around the same time the local climate data shows conditions rapidly improving. Here's the detail that makes this discovery matter far beyond a single lake in Wales. The commonly used benchmark for northwest European lake glacial warming comes from Greenland's ice cores, a genuinely excellent long-term climate record, but one representing conditions specifically in Greenland, not necessarily conditions everywhere across Europe simultaneously. The Llangorse Lake data revealed that southern Britain's local temperature record didn't match that Greenland pattern precisely. The warming here happened on its own local schedule, and in this case, it happened earlier. Researchers found that summer temperatures in this part of Britain jumped from a chilly 5 to 7 degrees Celsius up to a genuinely mild 10 to 14 degrees, in a shift abrupt enough to open up serious new grazing territory almost immediately. That's the kind of regional climate variability that's easy to overlook when relying on a single, distant benchmark record, and it's exactly the kind of nuance that determines whether migrating herds, and the humans following them, found a hospitable valley 500 years sooner than anyone previously calculated. For the small bands of hunter-gatherers actually living through this period, none of this would have registered as a scientific dataset. It would have simply felt like a good season, then another good season, then a valley that stayed green longer than expected. Life at this stage of British prehistory revolved almost entirely around mobility, following herds, building temporary camps, working stone and bone into tools, and making use of natural shelters like Kent's Cavern and Gough's Cave whenever the landscape and weather demanded it. These weren't struggling survivors clinging to the edge of habitability. The archaeological evidence from these sites shows organized hunting, deliberate toolmaking, and controlled use of fire, all consistent with a population that had returned to a newly workable landscape and was making full use of it. The genuine hardship had already passed, buried under ice sheets for thousands of years before any of this. What these particular 500 years represent is opportunity arriving slightly ahead of schedule, a landscape opening up just a little sooner than anyone previously realized. It's worth being precise about what this timeline shift does and doesn't change. It doesn't rewrite the broader story of when humans first evolved, or when they first reached Britain during earlier, warmer interglacial periods long before this particular ice age. What it does change is our understanding of exactly how climate recovery unfolded at the end of the last glacial maximum, and how quickly human populations were capable of responding to that recovery once it began. A 500-year adjustment might look small written as a single number, but it fundamentally changes the sequence of cause and effect researchers use to explain this migration. If the old, later Greenland-based date were correct, the story would be one of humans following a single, well-documented, continent-wide warming event. The revised, earlier date instead points to something messier and more interesting, humans responding to a genuinely local, specific window of improving conditions, well ahead of the broader regional pattern that most existing climate models had assumed applied uniformly across the whole of Northwest Europe. And that has real implications beyond this one migration. If regional, small-scale climate variability could meaningfully shift human movement by 500 years in this one case, it raises a reasonable question about how many other prehistoric migrations have been dated using climate benchmarks that don't actually match the specific, local conditions those populations were responding to. Llangorse Lake sediment core essentially serves as a corrective lens, a reminder that reconstructing the deep past requires as much local, ground-level environmental data as possible, rather than relying on a single distant proxy record and assuming it applies everywhere. The lake itself, quietly accumulating pollen grains, insect remains, and sediment layer after layer for 19,000 uninterrupted years, turned out to be a far more precise historical instrument than anyone excavating a cave floor could have assembled from bones and tools alone. So the next time you picture Ice Age Britain, it's worth updating that image slightly. Instead of a landscape that stayed locked in ice until one single, well-documented warming event finally arrived, picture something closer to what the evidence actually shows, a patchwork of regional recoveries, some arriving earlier than expected, quietly opening doors for reindeer, horses, and the small human bands following close behind them, all roughly 500 years sooner than the textbooks used to say. A single lake in Wales, sitting undisturbed for 19,000 years, was enough to catch that detail and hand it back to us. Which part of this story changed how you picture Ice Age Britain the most? That the warming here didn't match Greenland's famous ice core signal, that reindeer and horses effectively led the way back into Britain before humans did, or that a lake's sediment turned out to be a more precise clock than any cave excavation? Drop your answer below, and tell me where in the world you're watching this from. Subscribe for the next deep dive into the small details that keep rewriting Britain's deep past.